Hello everyone and welcome to Kanai's Real Lab. In today's video, we are exploring market basket analysis, which is a tool that reveals what shoppers buy. You can note sometimes supermarket uses this store layout, designing and plan based upon your own purchase data and associated with some rules behind it. So we will be working with a simple data set based upon the superstore, which looks like very small and kind of a jumble at first, but with the right technique, it becomes a gold miner for understanding the customer behavior. I mean, the key goal here is to uncover which product people are likely to buy together. This helps optimizing store layout, create cross-selling opportunities, and also offer personalized recommendations. So we will be importing some algorithm, basically a priori algorithm. So a priori algorithm, which we can take it from the mlxten library, and we will be doing the activity on the mentioned superstore dataset, and also a priori like algorithm we will be performing with Python. So before we begin into the activity, we need to have some prerequisite, nothing but we have to install some setup and libraries. So first we are going to install the basic and very important library for association rule, which is mlxten using pip install method. So pip install method is basically a method to install the library. So we will be installing mlxten. So this installation already completed, and we can take our a priori also association also rule from mlxten library. You can see later what happens. So we will be taking the pandas for data manipulation, and as I mentioned, mlxten we will be using for a priori algorithm and association rule also for transaction encoder process. So let us import the libraries also. Now we are going to load the dataset. As I mentioned, the load dataset using pandas read underscore function, and the dataset name is superstore, and I'm going to read two first rows of the dataset. So here, as I mentioned, each row represents the customer behavior. Each and every column represents the item in the basket. So after that, we will be going to apply some pre-processing steps. So step starts with converting the entire data frame which I have on the top, which is nothing but the data frame called superstore. From the superstore, I'm going to take each and every item and connecting into a list where the transaction at the last will be having a list of items. So once the list is prepared, then we are going to convert the categorical values into numerical values using the encoder function. We will be using transaction encoder this phase, and using the fit underscore transform function, we are transforming all the transaction into encoded variable. And for the easy analysis purpose, we are going to change our transaction data which is available in the list format into a data frame format. I'm going to print the first 5 rows of the data frame after pre-processing. So here is going to be our pre-processed data where every product becomes a column. So you can see here every product becomes a column, and each row shows the true or false depending upon whether the item was bought in that basket or not. So we then convert into a data frame for analysis. As I mentioned, this is the binary format Boolean data frame for a priori purpose. So before we apply our a priori algorithm, let us understand the structure of a priori algorithm. So this is a classical example of data mining and discovering hidden pattern present in the data. It works by identifying items that appear frequently and then iteratively combine them into a item set that satisfy minimum support and threshold. By the way, have you heard about this parameter, threshold, and support? And we will be understanding one by one. So, what is a priori algorithm? It's basically like a rule. We call it as an association rule or mining rule, where X to Y represents a relationship, and where the X is present, the item Y is also likely to present. There are some measures or measurables like support, confidence, and live, which will help validating the rule. So we can say that we have a one item for support, which is nothing but the support. For example, for a rule A to D, so the support is 2 by 5. So what is support then? The support measures how frequently item X and Y appear together. I can see here 2 times out of 5, this is appeared. That's why in rule A to D, 2 by 5 is the support value. Same time, the confidence indicate that the likelihood of Y will present given that the X is already present. It's just like a neighbor-based rule say that X is already Y is already X is already present, and what is the probability or what is the likelihood of Y will be presenting in this particular. So the another thing which is nothing but the lift, which quantify the strength of the association, showing how much more likely Y is appear with X than if they were independent. This is nothing but the value of lift increases. We can say that the association is so strong. So we need higher value of lift. So if you want to explore more about this parameter, just look at the picture and identify how this parameter support confidence lift is computed from the small given images. And this is going to help you more in computation, how this is performed. So we understood some basics of rule and we identified some parameter also. Now with that, we have a data in right format. We can apply a priori algorithm to find frequently item present in the data. So I'm going to convert into a name called frequent underscore item set. In this case, we set a minimum support of 0.03. So which means that we are interested in an items that appear at least 0.3 percentage of all transactions. So after creating frequent underscore items, we are going to sort the value in the descending order. So then we print the items. We just want top 10 items that occurs most frequently. Let me execute this steps as well. So we have top 10 item sets from this. I can see here mineral water, egg, spaghetti, french fry, chocolate is actually the order of hierarchy of based upon the support. The support is more for mineral water, which is basically based upon the frequency of this particular item present is more in this particular transaction. Next, we are going to generate our association rule based upon the frequent underscore item set prepared in the previous step. We set a minimum threshold of 3, which means that we are looking for a rule where there is a strong relationship than that what we expected by chance. So this is based upon rule, not by chance. So by rule, I need minimum threshold is 3. So I'm going to generate my rule metric. So I can see here the rule metric where each and every header represents antecedent, consequent, antecedent support and their confidence and the lift, conviction, Jacquard, certainty. There are a lot of parameters to evaluate a rule, whether the rule is good or bad. We are not going in detail statistics around the background. We just wanted to understand how to apply this. So after that, so we are going to have a small deep dive into filtering the rules. So we are going to setting a confidence value greater than or equal to 0.2 and also lift value greater than or equal to 0.3. And we need to have a length which is nothing but minimum product required in the basket should be greater than or equal to 2. So and also after that we are sorting the values based upon the lift and resetting the index. And after resetting index, we are just displaying top 10 rules from this particular data. Let me execute this. So here is the result, top 10 association rule. It says that these are all the rules and these are all the support or these are all the lift or confidence value to basically validate this rule is good. So for an example, so the line number 1 we have X frozen vegetable and soup, and the Y we have mineral water comma milk, which is having a support of 0.03, confidence of 0.383 and lift of 7.9, which indicates support of 0.3 percentage. That is a combination of course of transaction. It has also confidence value of 38.3, which customers say that the purchase soup along with this frozen vegetable has a good combination with the mineral water and milk. So this is what the confidence say that. And the lift value of 7.9 say that whatever rules we created or the prepared, that is very good. Anything more than 4, we say that the particular association is actually very good. So this is all about the association which identify more likely to be brought together. So hope this concept is clear. In summary, a priori algorithm is widely used in market basket analysis. It's used to find the frequent pattern in large data set, makes it very effective in applications across various industry. With that, we are closing this video on market basket analysis using a priori by Python. Hope you like the video and stay tuned for more informative content with Kanai's AI Lab.